Welcome to Network to Code's Nautobot installation series, where we guide you through an installation of Nautobot. In our first video, we'll review the tools, requirements, and steps required for deploying an instance of Nautobot using our Docker Compose project. To start, I will do a small introduction about myself. My name is Justin Drew. I am a principal engineer at Network to Code. I have 22 years experience within networking with about 10 years or more of automation. I am one of the lead maintainers for our Docker Compose and our SSOT projects. To begin, our Docker Compose project is comprised of multiple libraries that allow us to simplify management and ensure that all of the applications and packages used within the instance are compatible. To begin with, we are deploying Nautobot using containers. There is also the option of installing onto bare metal or virtual machines using systemd that you can find in our read the docs, but this video will be going and focusing on our container strategy. So to begin with, we utilize the Docker Compose project that allows you to define multiple services that are all interdependent, allows you to also define shared resources such as secrets and mount in files that might be required, such as jobs or other development code. In addition to that, we also utilize the Python poetry library for defining Python package dependencies. And utilizing it, you can define the applications and the versions of Nautobot that you wish to use, and it will determine all of the interdependencies between those packages, ensure that you use compatible versions. To make management of this instance easier, we also utilize a Python library called Invoke. Invoke allows us to write simple Python functions to act as tasks to then execute commands within the instance. These commands might be simple things as building, starting, stopping the instance, potentially doing a database export or import if you are potentially doing some sort of disaster recovery. In addition, it includes some commands for testing. So if you wish to go through the effort of including some validations of your environment, you can include that as part of your invoke commands. This also makes it much easier to then manage and run the containers, as it makes it as simple as running a invoke build or invoke start, invoke stop, instead of running a large Docker compose command. We will also be going over each of these steps once we've reviewed the various pieces. In addition, as part of these pieces, we are also able to support Postgres and MySQL databases simply by making some small modifications to our Docker Compose files, or even the invoke commands that are then used to call each of the databases. Ultimately, we strive for repeatability, stability, and simplification of managing the environment. In order to begin the installation of Nautobot, we must first do three things. To start, our first step is defining the Nautobot version that you wish to use with the project. This is done in the PyProject TOML file and must be statically defined, as it is used to create the container along with defining all of the various dependencies of your projects. Once you've defined your Nautobot version, you must then create your lock file. Your lock file is created with poetry and will be generated with a poetry update or poetry lock command. This lock file defines all of the Python packages and the supported versions for each, depending upon Nautobot and any other installed Nautobot apps or Python packages. Finally, to define your Nautobot installation, you must provide the environment variables and application settings for the instance. These are typically done via env files or will be defined in your nautobot underscore config.py file. We will also be reviewing each of these steps in the installation demonstration. As part of the Docker Compose configuration, it is defined using the Invoke files, the Docker Compose file. Now we will start with the steps that are required to build and deploy an installation of Nautobot using the Docker Compose project. The first step when starting the deployment of a Nautobot installation using the Docker Compose project is to first do a git clone of the repository to your local machine. This will make a direct copy of the repo on your local machine that you can then customize and save within your own version control history for any changes as you continue with the project. Once you have completed the clone, you will want to enter into the folder that it creates. By default, it is nautobot-docker-compose. With that, you will then want to do a poetry shell. The expectation is that you will already have poetry installed at the global level so that you should be able to do a poetry-v and see the poetry version. With that, we will then do a poetry shell, which will create the virtual environment for the project to ensure that all of the packages and various libraries are self-contained within this folder. Next, we will then want to do a poetry lock no update. This will create a lock file that contains all of the project dependencies that we will need for running this installation. With the poetry lock no update completed, we can see that there is a lock file. We will then do a poetry install no root. This will take all of the dependencies that were determined and placed into the lock file and install them into that virtual environment that we just created. To ensure that the virtual environment is properly activated, I'm going to first exit out of it and then re-enter into it. This is being done to ensure that anything that was previously installed and any hooks that were required for the maintenance of the project are then activated when I go back into the shell. So I have exited and then simply done a poetry shell, so I'm back in. I can then confirm that everything is installed appropriately with an invoke-l. This will provide a list of all of the commands that are available to us with the Python invoke library. As you can see here, we have an invoke build, an invoke CLI. There's an invoke create superuser, which will be handy later. There is an invoke db import and export that is helpful for any sort of disaster recovery or backup processes you might want to use. There's an invoke debug command that allows us to see all of the logs for the containers as you are trying to troubleshoot or determine issues within the installation. There's an invoke destroy command. This command is very sensitive and should be used with extreme caution as it will destroy any database volume that has been created and you will lose data. There's an invoke import Nautobot data command, which is used for importing Nautobot data that has been converted into a JSON file. There is also a migrate command that you might want to use if you have any new apps that have been installed and you might need to run any migrations. Finally, There are the Nautobot shell or NB shell command, which is used for troubleshooting, post upgrade, which it would also be used for any kind of app upgrades that you might need to run the post upgrade command, the restart command that will restart any containers, and then obviously the start and stop commands that will obviously start and stop the containers within the environment. With all of those explained, we will now move on to the steps required for building our environment. Now, in order to make reading and management of this project easier, I'm going to be utilizing Visual Studio Code. There is no requirement to use Visual Studio Code. You can utilize any IDE that you wish or simple text editors. To continue, to start, we will look in the PyProject TOML file. This file contains all of the dependencies that you wish to use within the project and any potential development dependencies, as you can see here. The first thing that is very important to notice here is the Nautobot version that is defined here. As you can see here, we are utilizing 2.3.2. The version 2.3.3 was just released, but you can utilize any version that you wish here, but you must statically define it. This is also where you would potentially want to define any applications that you would want to add in or any Python packages. There is an example here of our example plugin that we've included simply to demonstrate how the functionality would potentially be used here. The information that is kept up here can be customized as you wish and has no relevance to the actual deployment of your Nautobot installation. Once we have defined the Nautobot version, we have already created the poetry lock file that contains all of the version dependencies that have been defined and determined from the PyProject TOML file. Anytime that you manually update the PyProject TOML file or wish to add applications, you must rerun the poetry update command, which will then update the poetry lock file. With that defined, we will then need to go into each of the Docker Compose files or the env files to modify as we require. Assuming that you are deploying Nautobot using Postgres and are not terminating SSL at the Nautobot process, we can simply use the invoke.example.yml file. This file, along with the invoke LDAP and invoke MySQL file, are used as example files to make management of your installation easier. With Postgres, we would expect that you would copy the invoke.example.yaml file to invoke.yaml. So I'm just going to do that real quick with an invoke.cp.invoke.example.yaml to invoke.yaml. If we were to maybe want to deploy LDAP or MySQL, we would instead use these files. With that done, you can see that there is now an invoke.yaml file. The use of the invoke.yaml file defines the settings that will then be used when we are creating our Nautobot containers. As you can see here, it is defining the Python version that we're using. It is also defining where the compose files are, and it also defines which of the compose files we will be using for running our installation. If we did not have the invoke.yaml file defined, it will resort back to what is defined here within the task.py file. The tasks.py file is where all of the invoke commands have been defined. Now that we have defined the invoke file that we wish to use for deploying Nautobot, we will then want to create our env file. There are two env files that are included within the environments folder, as you can see here. They are both creds.example.env and local.example.env. The reason for having two of these files is so that the credentials that are stored in your creds.env file will not be synchronized to Git, as the file is included in the Git ignore. So should never synchronize any potential secrets to your Git repository. The local.env file will house anything that you wish to maintain and record within your version control history. This would be anything that is potentially non-sensitive, such as a banner, your changelog retention, or the settings of debug or your napalm timeouts, etc. When you are deploying to production, it is extremely important, however, that you review each of the settings that are in your env file and ensure that they are reflective of your expectations for your security measures that might be defined at your business. We will go over that in the second part of this video series, though. To confirm that all of the packages have been installed appropriately, we can run an invoke-l command. The invoke-l command shows that all of the commands that are available to us from the Python invoke library that have been defined in the task.py file. Now that we have that defined, we can simply copy our creds.example.env file. The creds.example.env file stores all of our secrets that we wish to keep. The creds.env file is special in that it maintains a list of all of the environment variables that we wish to maintain as a secret and not synchronized to our version control. The creds.env file is in your git ignore, so it should not be synchronized to your Git repository by accident. In addition, we also have an environments/local.example.env file that we will copy to local.env. This file is what defines all of the other required environment variables for starting the instance. Typically, with our creds.env and our local.env files defined, we can review the settings that have been defaulted from the examples. Each of these, as you can see, simply refers to settings that would be utilized during the installation of Nautobot. These can be customized as you wish, but please be careful, as changing some of these settings can potentially cause your installation to fail and can cause some odd behaviors. As you can see here, local.env is simply the database name, users, potential LDAP settings that are okay to be synchronized to your version control. The creds.env are settings such as your passwords, your secret key, or any potentially sensitive data that you do not wish to synchronize to Git. Now that we have defined these, we can run the invoke build command, which will pull the Nautobot container from the GitHub container registry, as you can see here. It will then install all of the relevant Python packages that are required for Nautobot and any of the other applications that you have defined within the project TOML file. Finally, it will copy all of the relevant files to a final image and harden it to ensure that when it is deployed, it has been hardened and has been deemed production ready. Once the container has finalized and been created, you can push this and store it in any container registry that you might want to utilize, such as the Docker Hub, GitHub container registry, or something like Artifactory. With it stored there, you can then reference this container in your, say, Helm charts for deployment into Kubernetes. Now that we have the container has been built, we can simply run an invoke debug if we wish to watch the actual startup process for all of these services, or an invoke start to see, since we wish to demonstrate all of the parts that are happening and what is going on. I'm going to go ahead and proceed with an invoke debug. As you can see here, it is going to start a database container. It will start a Redis container. It will start a Nautobot container. It will start a worker container, and it will start a Beats container. Each of these particular containers are relevant for the various operations of Nautobot. One thing to also be aware of is that the initial start of Nautobot can potentially take a long time due to the number of migrations and updates that take effect over the initial start, in addition to any schema changes that might be required when it is first starting up Nautobot. With all of the migrations completed, you will finally see some messages about some static files being collected. It will update any caches. And finally, you will see a log message stating that the service is running on your local system at port 8080. This can be customized, and we would recommend changes to it when you wish to change this into production. Now, with that being completed, we are going to show you how you would bring up the UI. So we're just going to go ahead and close out the containers from debug. So we are aware that it has now been started up successfully. We're going to allow the containers to stop. So we're no longer doing a debug, and then we will do an invoke start. That will restart all of the containers, but it will no longer be showing all of the logs to our command line. We can confirm that all of the containers are up and running by doing a simple Docker PS. You can then see each of the containers that is running from the Docker Compose project. Should you choose to change the name within the PyProject TOML, this particular portion would change based upon that, just so you're aware. We're going to give this a few seconds for all the services and everything to start up. To review, the important files to be aware of are the creds.env and the local.env. These are defined in the Docker Compose file. Any customizations that you wish to use with this, such as creating another instance that you wish to call something production or development, you would want to have a different env file for each. Along with that, there's the Nautobot config.py file. This contains all of the basics that are required for deploying Nautobot. The important parts to be aware of here is the plugins list and the plugins config here. Now that we have allowed for the services to start, we will want to run an invoke create superuser. This command runs the create superuser command for the Nautobot server. That will then create a superuser within the Nautobot UI for us to log in with. Just for testing, we're just going to go ahead and admin@ntc.com. All right, my superuser has been created successfully. To test this, I am going to go into, okay, so I have brought up a browser and I have gone to localhost colon 8080, and I am presented with this login page. I am going to go ahead and just create my admin here, and I am now in. I can confirm the version of Nautobot that I've specified has been installed. And I can also go to apps, installed apps, and see a list of any other apps that might have been installed. To review, we have gone over the usage of the invoke.example.yaml, the invoke.ldop.yaml, and the invoke.mysql.yaml files. We have gone over the Docker Compose files that are utilized by those Invoke files that define each of the services that are used within the project. And we have also reviewed the Invoke commands that are available to us that are defined in the task.py file. And in conclusion, we have gone over our understanding of each of the build components required for deploying Nautobot. Those components are comprised of the Docker Compose files, the Poetry library, and the Python Invoke library. Again, the Docker Compose files define the services that are used when running Nautobot. The Poetry library allows us to define our suggested or requested applications and Python packages and determines the dependencies and compatible versions for each. And finally, the Invoke library allows for us to simplify maintenance and management of the Nautobot installation. We have then gone over each of the required installation steps. But first, by defining the desired Nautobot version we wish to install, then creating our lock file that determines or defines all of our versions that are required for installation. Finally, by running the invoke commands that will build the container. And finally, by defining the application and environment variable settings within the env files and the Nautobot config.py file. We have gone over each of the compose and invoke files that defines the various settings that we wish when we are deploying Nautobot. And then we have demonstrated each of the steps required for deploying Nautobot. Thank you for joining us on the first of 2 installation videos. Be sure to watch our second video, which furthers the installation process.